3 for day 2 today. So we're going to focus on arithmetic sequences, but we're going to do the explicit rule instead of the recursive. And we are going to have to know the difference. So the first thing I want to do, though, is kind of go over what we did yesterday. So I need you to do numbers 1 and 2, but number 1, this should be a -2, not a -3. That makes it an actual arithmetic sequence. So go ahead and pause the video, try these, and then I'll go over it. So you should have enough time to have that done now. And if you notice, each one of these is subtracting 3. So that subtracting 3 would be the common difference of -3. Identifying a sub 3 means the third term. So the third term in this sequence would be -8. Finding the next term means I just need to take -11 and subtract 3, which would give me -14. And then writing the recursive rule, remember we always have to identify a sub 1, which in this case is -2. And then we need to write a sub n equals a sub n minus 1, and then the difference, so -3. For number 2, it said the recursive rule is a sub n equals a sub n minus 1 plus 2. So remember this is your difference, right? And then we start with -1. So find the first 5 means I'm going to start with -1, and then I'm going to add 2 over and over and over again. So 1, 3, 5, 7. All right, so we're going to talk about the explicit formula now. And this is the actual formula, and you can always plug into this and then find your equation that way, but it is much simpler than what you think it actually is. Okay, so where it comes from is you have a sub n, which is just the typical label, equals a sub 1, so we actually have that in our equation now, and then plus n minus 1, n being whatever your term is, times your difference. Okay, now you never want to leave it this way. You'd have to take your difference, distribute in, and go from there. Okay, but this actually does kind of turn into slope-intercept form. It's very, very close to it. Okay, so we'll see that in a little. So for this first one, it says, given the explicit formula, find the first 3 terms of the sequence. Well, if I want to find the first 3 terms, I would start with a sub 1. That means that I'm going to take 1 and plug it in for my n values. So we have 2 times 1 plus 1, which would be 2 plus 1, which is 3. The next term would be when n is 2. So we have 2 times 2 plus 1, which would give me 5. From there, our last one would be 2 times 3 plus 1, which would be 6 plus 1, which is 7. Once you get 2 of them, you could have noticed that you just are adding 2 each time, so you didn't have to do the last one, but our answer would be 3, 5, and 7. Now, if you notice, okay, we are adding 2, which is what we were multiplying by here. So your difference is linked to your slope of the line, right? Because if you notice, a sub n equals 2n plus 1. It's kind of like f of x equals 2x plus 1. Okay, it's the same situation. And this is when x is 0. So this is your y-intercept. Okay, so this is your a sub 0. So you just go backwards 1. And you'll see that in a second. All right. It won't let me move up. What the heck? There we go. All right, so first one, it asks us if this is an arithmetic sequence. And if you pay attention to the numbers, what's happening is this is decreasing each time by 5, right? We're subtracting 5 each time. So yes, it is, right? And d equals -5. Write an equation for the nth term, okay? So for this one, we're going to write an explicit one, okay? And You can always plug into the equation a sub n equals a sub 1 plus n minus 1 times d. Okay, so I'm going to show you that way, and then I'm going to show you the much faster way. If we do it this route, which is totally fine, you would take 4, because that's my a sub 1, then plus n minus 1, well, yeah, n minus 1, and then times your d, and our d is negative 5. So we're going to have to distribute that negative 5 in, and then we have to combine like terms. So a sub n would equal negative 5n, and then plus 9. Now, you can get the exact same thing in a much faster route. Remember, I told you that first number is always going to be kind of like your slope. This is in slope-intercept form, so it's going to be your difference. And then the last number is going to be one the opposite direction. So if we're subtracting 5 for all of these, we would do adding 5 for this, which would be plus 9. And that gives you the exact same thing. Now it says what would be the 90th term? So that means that we're going to plug 90 in for n. So we have a sub 90 equals negative 5 times 90 plus 9. Okay, so again, order of operations, you need to multiply before you add. So we have 5 times 90, which is negative 450. And if you add 9 to it, you'd get negative 441. Now, if we're going to go graph this, remember this is a kind of like a linear thing, but we don't actually draw the line, right? So remember, this is the first, second, third, fourth, fifth term. So we use those as our x's. So 1, 4, 2, negative 1, 3, negative 6, 4, negative 11, and then it would be off. Okay, now again, do not connect to those because it's not a line. We're just talking about the sequence. All right, so it says write an explicit formula for the arithmetic sequence here. Okay, now this is a recursive formula. So I know that negative 3 is my difference. So using what we did before, I know that's going to be negative 3n. So now I just need to figure out what my y-intercept is. And remember, your y-intercept is kind of like a sub 0, right? So we base it off of our a sub 1, right? I know my difference is negative 3, so every time I move to the right, I would subtract 3. So I just go 1 in the opposite direction, and I would add 3. So if I'm at 10, add 3, I'd be at 13. And that would be my a sub 0 or my y-intercept. Okay, again, you're more than welcome to use this formula over here, but it's much, much longer and I think a much more confusing process. Number 4, we are going to write an explicit formula. So again, we're really looking at a sub n equals kind of like our slope, right? So our difference times n plus a sub 0, okay? So first off, we need to find our difference. So if we're looking at these are going up by 16 each time. That's a lie. They're going up by 12. That was really good math. I'm sorry. They're going to go up by 12. Okay. And obviously these are going up by 1. All right. Now, again, remember, this is typically backwards. So whenever it's like 1, 2, 3, 4, 5, 6, 7, 8, that's going to be x. This is going to be y. And remember, y is your dependent variable. And your cost is going to depend on the number of days. So that's why it's x over y here. So when you're talking slope, it would be 12 over 1, not 1 over 12. But again, we're really thinking about it as a difference anyway, so the difference is 12. Now the only thing left to do is figure out what a sub 0 is. So if we go 1 backwards, I would be subtracting 12, which would put me at 14. What is the cost of renting a bicycle for 10 days? So that means we're actually finding a sub 10. So 12 times 10 plus 14. This would be 120 plus 14 which would be $134. All right, so the last part right here is just saying how the explicit rule or explicit formula is related to a linear function, okay? And again, you basically can say stuff like your difference is the same as slope, and your a sub 0 is the same thing as your y-intercept, right? So we're plugging it in. A sub n equals d times n plus a sub 0 versus f of x equals m times x plus b. Okay, so it's very, very similar. The cost to rent a bike is $28 for the first day plus $2 for every day after that. Okay, so for each day, meaning that's kind of like your slope, right? So I know that's my slope, and 28 is where you start. So this would be my formula. Okay, again, very similar to what you would have done in last unit. What's the cost for renting a bike for 8 days? So we're going to plug in 8 for n. So we get 12 plus 28. Oh my gosh, I did it again. Apparently 12 and 16 are the same number to me today. So at least I wrote it right. 12, oh my God, 16 plus 28 gives me 44. My gosh. So it would cost $44. Number 6, it says write an explicit rule or explicit formula for the sequence shown by the graph. So remember, this is, first term, second term, third term, and so on. So we need to go one backwards to help us out here, okay? So that is going to be helping us, that 50 is going to be that a sub 0 that we need. And the difference is kind of like slope. Well, my slope, I'm going down 5 over 1, down 5 over 1, down 5 over 1. So my slope would be a negative 5, and my y-intercept, or my a sub 0, is 50. So if I wanted to find a sub 30, it would be negative 5 times 30 plus 50. That gives me 150 plus 50, which is negative 100. The explicit formula for an arithmetic sequence is a sub n equals 1 plus 12n. What is the recursive formula? So remember, for recursive, I do need a sub 1. So we can just plug in 1 here, and we would get 1 plus 12, which is 13. So part of my formula would be a sub 1 equals 13. Now, in the explicit formula, there is something that is our difference, right? There is one of these two numbers that is specifically our difference, which is 12. So I'm going to use that to help me write the next part. Because remember, it's just a sub n equals a sub n minus 1 plus your difference. So it would be plus 12. Now after this, in our notes, there is a nice chart for you that can help you potentially. They do use the explicit formula with this equation and solve it. And maybe that's a preference for you, and that's totally fine. You're going to end up with the same answer as long as you are consistent with it. So either way is fine. And then here is the recursive formula as well.